Do you know that medicine, as we know it, will be completely revolutionized? Are you curious to know why and how? So, let's make an imagination exercise. Let's imagine a world where medicine is a personalized matter. Let's imagine you have a condition like a recurrent stomach pain, and now you're trying to balancing out with some medicine that sometimes do not work. Now imagine you still have that pain, but you get your gastroscopy done, and after a couple of weeks, you receive the right medication that will make you feel effectively symptom-free. That's pretty cool, right? Now imagine something more serious, like a cancer. How many times have you heard about first, second-line treatment, failure or recurrences? What if we could know exactly which drug will be able to fight that specific tumor? What if we could also know how that tumor will behave in the future, acting beforehand? Now imagine you to be a patient in an endless waiting list, hoping for a heart or a kidney to be available for a transplant. What if you could get that organ without waiting endless years for somebody else to die in a car accident? And what if having that organ will not put you at risk of rejection because it might come from your own cells? Well, today it's possible to regenerate cells in vitro from your own cells, making organoids. Organoids are the key to make those scenarios reality. And today, I'm going to explain you why and how. Today, I'm going to explain you why organoids have the revolutionary potential to change medicine, but also our life. So, what are organoids? Organoids are made of cells, and they represent a miniaturized and simplified version of an organ. They are made of cells created from humans. They are able to self-organize in the 3 dimension, resemble a small organ in a dish. I want you to draw your attention on these 3 words that will come back later: 3D model, self-organized, and human-derived. I know that your mind is already puzzled by some question like, what do you mean they resemble the function of an organ? Well, for example, if we think about the lungs, the smallest functional unit of the lung is called alveolar sac, and is the one that allows us to make the gas exchanges in our lungs. Well, lung organoids don't look like a small inflating and deflating lungs by their own, but rather they resemble the smallest functional part, the alveolar sac. So, how do we make the organoids? First of all, we take some stem cells. In our body, all the organs have those stem cells that are the one that repopulate the organs and allow us to live up to 100 years, healthy and functional. We can extract them from many reachable tissues, like our skin or our stomach, through the biopsies. But as you can imagine, not all the organs of our body are so well accessible, like the brain. And to create organoids of the brain, we can use either embryonic stem cells, or we can program other cell lines, like skin, back to embryonic stage, and then back again to become any other cell type. So when we have those stem cells, we put them in a matrix that sustains them as a scaffold. We give them the right cultivation cocktail, which contains every factor that they will find in the real body to make them feel home. And in those conditions, they expand and they dispose in a 3-dimensional, creating organoids. I see a lot of question marks in your eyes, so I think that by now I should clarify what organoids are not. Of course, they are not fully functional organs. They are only the small brick that make the organ, not the full architecture. As we can see from the image, it's clear the difference between an organoid and a real brain. They are not big enough. They are only 1 millimeter in size. They are not vascularized, and here I want to say yet. And due to the fact that they are not vascularized, they cannot reach the late stage of the development. Now, we define what an organoid is and what is not. I want to come back to the 3 words I asked you to remember: 3D model, self-organized, and human-derived. Do you know that all the important discoveries that have been made in medicine in the last centuries have been done studying immortalized or cancer cell line in 2D or with animal models? Let's think about that slowly. Despite the fact that we are actually in 3D, humans, and definitely not immortalized, I think that we did a pretty good job. Can you see the opportunity now? Can you imagine the boost that research will get if all the future studies will be done in 3D from human cells that are able to self-organize in a 3D dimension? Those cells know where to go and why. They know how to expose themselves in a 3D dimension. This is not only amazing by the scientific point of view, but could also potentially tell us so much about organ development. Why the organs have the shape they have, and how and why they lose their shape in disease. Organoids give us the personalized therapeutic potential. We could create avatar of a tumor or a cystic fibrosis organ and test the drug on those avatar without losing time with the wrong therapy, alleviating pain, and potentially saving lives. We could improve our drug development ability, drastically escalating our trial size, which might be already a game changer for all the rare diseases that by now don't have enough participants in clinical trials. Then we could understand how a genetic defect creates a specific phenotype, fix it with gene editing, and inject the right version of those organoids back to the patient. I'm sure that by now all of you are amused by this technology too, and you would like to quit your job tomorrow, coming with me in the lab doing fascinating science. However, unfortunately, not all this biology for now is done in 3D. It's still done mainly in 2D. That's why it's important to talk about this, and that each scientist will engage with the use of this 3D model. I personally use organoids for my research. I study precancerous lesions in stomach. And I'm sure that in the future, we will be able to even prevent some disease to happen, just understanding them. I'm sure, I hope at least, that in a not too distant future, we will have biobanks in which healthy people like me can donate their own cells to create organoids for other people, like we now do with blood. I'm wondering, will we be able to even implement this technology to achieve even more? I hope to have installed you some hope and trust in research, and to have convinced you about the power of organoids for our future and our lives. Thank you.